Bismillahirrahmanirrahim. Starting with the greatest name of Almighty Allah, who is the most merciful and the most beneficent. Chemistry scientists, Assalamu alaikum. Hope you all are doing very well. Today I am welcoming you to an amazing world of solutions, because the one who is not the part of the solution is a part of the precipitate. Therefore, I warmly welcome my cute audience to this fantabulous journey, because without chemistry you are not even cute. Myself, Kinza Shafiq, and today the topic we are going to discuss is how to make a solution. It is presented to our most respected and the multi-talented professor, Dr. Hammad Majeed, who always used to say, so the students also follow their mantra and speak it loudly in a single voice that this is the main topic of our presentation, that prepare the normal solution of an acid by using dilution method. Moving towards the content, so we have to discuss this content is basically divided into two parts. Number one is the theoretical work and the number two is the practical work. In number one, theoretical work, there are things to be explained like main topic, intro, calculation, formula and statement. In the second part, we are going to discuss the lab precautions, apparatus, procedure and the most important and the awaited thing, the practical performance video. And lastly, we are going to discuss how to standardize a solution. Theoretical work. Our main topic is basically prepare 0.5 normal H2SO4 in 500 ml from 16 molar H2SO4 by dilution method. Now observe the statement carefully and detail all the things like 0.5 normal. We are going to discuss what is normal solution. Then 500 ml from 16 molar. What is molar solution? Then dilution method. What is it? H2SO4. We are going to have a quick and small glimpse on all those things. So normal solution. A normal solution is one which contains 1 gram equivalent weight of a compound in 1 liter of a final solution. As you can see, the normality is equal to gram equivalent weight of solute per volume of a solution in liters. Now, how to calculate an equivalent weight? It is very simple. Equivalent weight is equal to molar mass divided by N, where N represents the number of hydrogen atoms in an acid and or hydroxide ion in a base. Let's see it with an example. Let's say that molecular mass or molecular weight of H2SO4 is 98 gram per mole. As you know that H2SO4 gives 2 hydrogen atoms in water, so N would be equal to 2. So when you divide 98 gram per mole divided by 2, the answer would be 49 gram. So when this 49 gram is dissolved in 1 liter of a solution, it will be called as a normal solution. Next, the molar solution. A molar solution is defined as an aqueous solution that contains 1 mole of a compound dissolved in 1 liter of a solution, or number of moles of a solute dissolved in 1 liter of a solution is called molar solution. As you can see, N is equal to number of moles of solute and V is the volume. You can see it and understand it simply by an example. For example, the gram molecular weight of sulfuric acid is 98. 1 mole of a substance is 98 gram. If this amount is dissolved in 1 liter, then the combined substance qualifies as a molar solution, as it can be said that we have a 1 molar H2SO4 solution. Dilution method. Dilution method is basically a common method of making a solution of a given concentration. Involves taking a more concentrated solution and adding water. until the desired concentration is reached. This process is known as dilution. Properties of sulfuric acid. As we are discussing sulfuric acid in this whole solution experiment, so we should have some basic concept of what is sulfuric acid and what is its properties. So sulfuric acid is thick and colorless. It has pungent odor. It releases heat. Sulfuric acid is a dehydrating agent with hygroscopic qualities, which means it may draw and hold moisture from its surroundings. Lastly, this chemical is highly corrosive and reactive. It has a very high oxidizing power and thus acts as a strong oxidizing agent. Sulfuric acid, it is a basic information that sulfuric acid is a king of chemicals. Now, our main topic is the calculation of this whole statement and get the answer. Now, the proper technique is that whenever you see the statement, you must recall the basic concept of the things given in the statement. Let's see that our statement gives us one value, which is 0.5 normal in 500 ml from 16 molar H2SO4. Now you can see that it would be our given data. So what would be it? C1 is equal to 0.5 normal. This value given is actually our C1 and this is our V1. Now you can see that by recognizing these things, you can easily recall the formula of dilution, which is C1 V1 is equal to C2 V2. Now, what are we going to find is C2 and V2. For this, we will first solve the C2. So, as H2SO4 gives 2 hydrogen atoms in water, so its 1 molar is equal to 2 normal. And 1 molar, that molar value is given in the statement, that is 16. So when 16 divided on both sides, the answer is 32 normal. So our C1 is equal to 32 normal. Let's go and move forward to the V2. For V2, we are applying the formula C1V1 is equal to C2V2. Now we have C1, V1, C2 and V2. We are going to find only the V2, which would be our answer. So by putting all these values in the formula, we'll get the V2. Now, clear this concept that this is not our answer. This is only a value that we get from the formula. Our answer would be this statement. This is the crest or lifeline of any experiment. Statement would be your answer. So whenever you do any experiment, please careful about writing a statement and always write that because it is your answer. So our statement would be, this answer of ours is written in this sense that 7.812 molar of 16 molar H2O4 is dissolved in 500 ml to obtain 0.5 normal H2SO4. So this is our answer. This statement is our answer that how much of 16 molar is dissolved to obtain 0.5 normal. Okay. Now let's take a ride to the lab now. Ensure lab safety first. Before going to the lab, you should know the safety rules of the lab and you should follow all the precautions carefully. So be safe in the lab. Following are the important precautions you must follow in the lab, like wear safety goggles to protect your eyes, gloves to protect your hands, shoes to protect your feet, wear lab coat, tie back your hair. Don't eat or drink in the lab. Don't try to smell or taste chemicals. Read instructions before mixing the chemicals because different chemicals have different reactions. If you break any lab equipment, inform the attendant immediately and do not try to keep that bare-handed. So dispose of all the chemicals after use. Follow all the instructions given by your instructor and carefully note his directions and instructions, because it is very risky if you don't follow the instructions. So keep calm and don't break the lab equipment. Let's see a small funny video here.
Smell indirectly. Don't smell. Don't go inside. Where's it? Don't go. Read instructions of the motion tester. Don't randomly mix things. No report chemicals back into the original container. Okay, so it's a broken glass. Okay, I'll take a glass with bare hands. No horse boats in the lab. Wash eyes with clean and immediately when disposable. Oh, safe.
So the most important precaution of ours is always add acid into the water, because adding water into the acid is very dangerous. Let's have a look at this. The reason behind is the density difference. As you can see in these two beakers, the main difference given is of the density. Water has a low density of about 1 gram per cubic centimeter, whereas an acid has high density of 1.8 gram per cubic centimeter. Adding acid into the water is safe because acid has high density and it floats into the lower level of water and makes a solution with it. Whereas when water add to the acid, it would be very, very dangerous because the water has the low density and it only gets on the surface of the acid, and due to the exothermic reaction there would be the splashes coming out of this solution and it would be very dangerous. Next, talking about the apparatus, the required apparatus is the two beakers, one of 100 ml for pouring the acid and the second one is of 500 ml for water. The glass rod or stirrer for mixing the chemicals, the pipette to suck the sulphuric acid, funnel to keep it safely into the flask, dropper, to add small amount of water when this water reaches near to the mark, and the measuring flask. Use this measuring flask always and always cap it after use and name the solution you made it. So the main flask of 500 ml is required. Procedure. Take a first beaker. As you can see in the apparatus that we have two beakers. So take a first beaker and fill 300 ml of distilled water. Then take a second beaker and fill 100 ml of H2SO4 from 16 molar concentrated H2SO4 bottle. Because sulphuric acid in the large bottle would be difficult to suck it and pipette. Now take a pipette and suck H2SO4 from the beaker 2 up to required value, that is 7.6 ml. It comes from our calculation. Pour down carefully the sucked 7.6 ml H2SO4 into 300 ml water. And always remember, add acid into the water. Mix the solution with a glass rod or stirrer. Remember that always make a solution in a beaker and then convert it into the flask. So our last step is lastly convert the solution into the 500 ml of measuring flask with the help of a funnel and add water up to the mark. Continue adding water till the solution comes near to the mark, and when it is up to the mark, the solution is totally ready, and now confirm it by adjusting your eye level. This flask has narrow neck, so for accurate reading it is used. Okay, we are going to the lab. So leave lab and love always like helium. So the most important and the most rated thing is here, the practical performance video. Let's have a quick glance at how to make a solution. This video is very helpful for making a solution. So this is the video. By seeing it or watching it, you can easily make a solution of normal now. So how to standardize a solution? As you can see, the text boxes in the captions given in the presentation video. Need to standardize a solution. What is the need that how we standardize a solution? The calculated value is 7.8125 ml, but we can't repeat this, so we stop our measurement to 7.8 ml. As in this experiment, instead of using the exact value that is 7.8125 ml, we are using a vague value that is 7.8 ml. As we are using the vague value, not exact, so that is why we need to standardize this solution. Not this, but all the solutions, so that we can use it in the research and get the accurate results. So how to standardize a solution? As we know that H2SO4 is strong acid, so for this we need a primary standard alkali. In this experiment we use this primary standard as Na2CO3 sodium carbonate. First step is we also make the 0.5 normal solution of Na2CO3 and then titrate this with the given solution of our 0.5 normal H2SO4. Then we find the molarity of the acid. The molarity of primary standard is already known because the primary standard is the one which does not change its molarity and concentration. So we do actually this method to confirm whether our solution made is exactly 0.5 normal or 0.49 normal or 0.51 normal. So by titrating or by standardizing the solution, we get a result that we have checked our solution and it is about 0.85 normal, which is very close to 0.5 normal. Now we can easily use this in research. So this is the method how to standardize a solution. Okay, G. The journey seems to coming to the end. Okay, genius audience, if you have any question about the topic, you can free to ask, because the Mary Curie says that be less curious about people and more curious about ideas, and learn to ask the questions because the knowledge comes from asking the questions. So thank you so very much. I hope that you enjoy the video a lot. So good luck, have a nice day, and Allah Hafiz. Lastly, in the end, I would like to say that love chemistry and enjoy the chemistry. This is not the end, because what feels like the end is often the beginning. In the end, everything will work out, and if it doesn't, then it's not the end. So thank you so much. Allah Hafiz.